The next question is the painter's partition problem. This is a GFG hard. Let me just quickly tell you what the question is telling. The question is telling that you are given with integer array ARR and an integer k. Now what is this ARR represent? Boards of different size. Suppose this is a board of size 10, then there is a board of size 20, something like that. And these boards over here, they need to be painted, and to paint a board of 10 units, it takes 10 units of time. For painting a board of size 20, it takes 20 units of time, and so on, right? And what is this k? This k is the number of painters that you have hired. So you have a wall or a board of different sizes to paint, where the size of the board is itself representing the time required to paint that particular board, and also you are given the number of painters that you have hired. The next constant is that, guys, you have to allocate all the painters with at least one wall, that is a constant. And the second thing is that what you are looking in output is that you have to minimize the time required in order for all the painters to finish the job. What does that mean? Let us understand. Suppose if there are two painters, all these walls must be divided into two parts and they must be assigned to these painters. So there is a possibility I take this 10 on, like there are two painters, right, painter 1 and painter 2. So in painter 1 side I can take 10, on the painters 2 side I can take 20, 30, 40. On over here I can take both 10 and 20, over here I can take 30 and 40, or over here I can take all 20, 10, 20, 30 and leave 40 for painter 2. This can be one possibility. Obviously 4 on this side and or 4 on this side, these two things are not allowed. I have to assign one at least to any one of these painters. So these three are the possibilities. Now if you look at all the possibilities, if I see in the first possibility it was 10 on one side and this on the other side. Over here the maximum is obviously this side. So this side, how much unit of wall you need to paint? 40 plus 30 plus 20, which is 90. Now to paint this 90 you need 90 units of time, and the other painter will take 10 units of time. So obviously for both the painters, for the k painters to finish the task, it will be 90 units of time, which will be the maximum of each painter's work. Now if I divide this 10 and 20, then this painter will take 30 units of time and the other painter will take 70 units of time. Among these two I need to take the max. Obviously the max is 70. Previously the max was 90, then it came down to 70. Let us explore the other options. One painter will be assigned with this, so he will take 60 units of time and the other painter will take 40 units of time, and I need to find the max of them. So max is this time 60, sorry. So previously it was 70, now it became 60. Previous to that it was 90, so basically this became my minimum. So this is the allocation that I need. So the optimal is if I take this for painter 1 and this for painter 2. So this painter will take more time, which is 60, but that should be the minimum way to allocate the painters. That will be the minimum time in which all my walls will be painted by these two painters, right? One painter will take all these three and the other painter will take this. So this painter will take the maximum time, which is still the minimum from all other cases, right? So in this situation over here, just like the previous questions, this question is very much related to the previous question. Also maybe after a couple of days you will get a new question, which is allocate books. There also the question is going to be almost the same. So if you have attended the last video properly, this will take a very shorter time to complete. Okay, so what I am saying is that these are the length of the walls or the boards, right? So at a time any one painter can paint any one wall, right? I cannot assign like 10 units of this wall I will assign to one painter and 10 units I will assign to another painter. That is not an option. The entire wall should be painted by one painter, right? So the output for this particular input is 60, because this is the minimum time that is required in order to complete the task if we divide it in proper strategy, right? And also just like the previous question, we cannot allocate different walls, like the walls have to be allocated in order to the painters. We cannot assign this wall and this wall to a single painter and the rest of them to the other painter. We cannot do that. We have to assign the painters in sequence, right? So this is the question, guys. So now if I try to find out that what should be the range of this answer, I got 60. Now, is there a particular range of this answer? The answer is yes. I can assume that the minimum amount of time required should be the maximum wall, at least this much time I will need, because any one of the available K painters will need to paint this maximum wall. So at least this much time I will need. So the output shall start with the range of the output. If I want to calculate, then the range of the output will lie somewhere in between the max of these elements, max element, and the total summation of all the elements, sum of all elements. Obviously sum of all elements is a little bit more, the range is a little bit overstretching, because all the boards will not be assigned to a single painter. So it will be divided among K number of painters. So basically never will one single painter get all the boards, but still I am considering that the max element is the starting point, this much time I require, this is minimum, and my maximum is, my max is the summation of all elements. I hope this part is clear, just like the previous question. Now, as we have found out that the range is from 40 to 100, which is the summation. So in this range, what I can do is I can start with this 40. I can check, if I take the minimum time as 40, then how many painters will be required. Just like in the previous question, what we did was, in capacity, we had a ship capacity, we assigned a particular weight to the ship and then tried to find out that if this is the weight, how many days would it take for all the packages to be delivered. Here we are taking that, okay, so 40, if I take that a painter can paint a maximum of 40 units of wall, then how many painters do I need? I can calculate that very easily. Suppose for 40 I calculated how many painters are required. Suppose that painters are greater than whatever the required number of painters we are hiring. This many painters we are hiring. Suppose for 40, obviously you can see that the output is 60. So for 40, if I assign 40 units of maximum work to one painter, then the number of painters will turn out to be greater than 2. Once it turns out greater from this 2, what I will do is, it was earlier 40, then I will make it 41. Now I will try to do it for 41 and then find out the K, and then I will go to 42. So now within this range I can linearly iterate to all the given weights. Whichever board size will be giving me that can be covered with the 2 painters, I will take that as my answer. Because I am iterating from the lower end, I will get the lowest time in which the painters will paint the boards. I will get the lowest time, so I can return that result. But this over here I have discussed earlier as well. The time complexity will be summation of all the elements in the array minus the max into, for each one of these range I need to iterate through the whole array in order to find how many painters will be required for a given maximum limit of a painting board. So it will be cross n, which will be the size of the array. So somewhere this is also going quadratic. But the optimization is, guys, as we are having a sorted range over here, why do we need to calculate 40 and then 41 and after that we move to 42? Why do we need to follow this linear fashion of iteration? We can just find out the middle element and try to compare, if for the middle, wherever the middle lands, if that I take as the maximum allowed capacity to paint for a painter, then for that capacity how much painters are required, that many painters I will try to compare with the given number of painters, and accordingly I will either move my start or I will move my end, right? And also at the end I will return my start, whichever my left or low or start, that I will return. This why this was also covered in the previous video. I hope the logic is now clear. Here the binary search is that this range over here is sorted. So instead of linearly traveling through it, I can deploy binary search over here, and this n will then be converted to log n. This component will remain the same, sum minus max, but it will be now multiplied with logarithm of n and not n. That is the only difference. Let me quickly code it up for you guys. Cool. I will find out, it is just similar to the previous one. I will find out arr.length After that what I will do is make two variables, one is the max capacity and the other will be the mean capacity. Okay, I will be assigning both of them to 0, right. Then I will iterate through the whole array for int I equals to 0, I less than n, I plus plus. Then what do I do? For calculating the max capacity will be the summation. So sum also this variable. So max cap, basically max cap will be incremented by the current element, right. And also in my mean cap I should store the maximum until now. So the maximum of the array I need to store. So mean cap comma the current element, whichever will be greater, that will be stored in mean cap, and mean cap will be our minimum capacity, that will be our start pointer, right. After getting the mean capacity and the max capacity, what do we need to do? I need to deploy binary search on them. So while my mean cap is less than max cap, obviously guys, number of painters that we will get for a particular mid, if that is greater, then we do start equals to mid plus 1. Otherwise, if the amount of painter that are required is lesser than what is given or equal to what is given, still we search the space ahead. There, for searching the space ahead, we should not exclude the current mid from our answer range. That's why we move our n to mid only, and for that reason only we are not using the equals to sign that we use in binary search normally over here. All these things are explained in the previous videos. I'll move ahead. I'll calculate the mid over here, which is equals to mean cap plus max cap minus mean cap divided by 2, right. After that I need to take this variable's capacity, which I will assign it to mid, and also I will take the number of painters that are required, which I will assign it to 1. Also this logic, how we will calculate the number of painters required for a given capacity, that also was covered in the previous video. Now what I will do is I will iterate through the entire array once again. Int I equals to 0, I less than n, I plus plus, right. Then I will check if my capacity is greater than, if it is less than my current element. If the capacity is less than my current element, I cannot accommodate it with the same painter, like the maximum limit that is set for the painter, it is getting crossed. So what I will do is I will increase the number of painter. So painters will be incremented, and obviously if a painter is incremented, then the capacity is also reset. This new painter can paint a maximum of how much? Mid, that much he can paint, and regardless of if the capacity is less than or greater than, I should always decrement the current board size from my capacity. So my capacity will be decremented by how much? The current element, right. After coming out of this for loop, basically what I will have is that I will have for a particular mid, if this mid is assigned as the maximum unit of wall that a painter can paint on a day, then how many painters are required? That is what we are calculating in this array, right. After that I will just check if the number of painters are greater than k. So I need 2 painters, I have hired 2 painters, but if I set the current mid as my capacity, then I will be needing more than that painters. So what I need to do, I will need to increase the per head limit of the painters. So basically what will happen is my mean cap will go to mid plus 1. In else case, obviously my max cap will come down to mid, not mid minus 1, right. So that's the case. And after that, this also I explained in the previous videos, why after every time I will return my mean cap, right, because at the end I told you the situation where consecutive elements will be pointed out by start and end pointer. So in both the cases, if start pointer, whichever the start pointer is pointing to, if that becomes the answer, then also start pointer remains there. Otherwise the start pointer is incremented and it becomes equal to end, and mean cap, and it should be strictly less than the end, right. So basically the iteration ends and still the start is pointing to the given answer. I have already told this. So yes, this is the code, quite simple. This is a GFG hard, but if you know the if you know the family of these questions, then you know the pattern, and then you can do it. Also, a couple of days later you will be getting allocate books. Try to do that, try to read the question, figure it out on your own. It will be kind of the same thing, right? Thank you guys.